So good evening, ladies and gentlemen. Welcome to this presentation. What a great day. It has been amazing. It's good to see so many of you. Thanks for being here. So as you can see on the title, we're going to use SQS and SNS, which are basically two distinct AWS services, in order to build reliable, scalable, and secure, and loosely coupled applications which are going to empower your business. So let's get started with this. So here is a little bit about me. So I am Belkalem Jugurtha, and I am an embedded systems engineer. I hold the Solutions Architect Associate Certificate. I work for Smile Open Source. Our daily job is helping our customers to build and create innovative, smart, and connected devices. So we embed the operating system, we customize it when necessary. In order to fit into a small space, we provide the application layer and as well as the connectivities to some cloud providers. Most of the time, it's AWS. So why this talk? So why we are here? I came across a situation where a company had a similar network topology. So we have 3 VLANs. They have enabled the trunking port on the switch. They have used the 82.1 queue in order to encapsulate the traffic coming from different VLANs into a single router interface, which was good for their business. And then some days later, they started releasing their first product, which was connected. It was communicating back information through the MQTT protocol to the IT network VLAN. But more devices they were selling, more latencies were observed until one day everything stopped from working. Yes, and all the devices' data were lost. This is an example of strongly coupled system which lacks support for offline mode. So how can we use AWS in order to fix this issue? So let's get started with this. Let's start with SQS. SQS is a simple queue service. Yes, it can hold messages so that devices can publish and send data. The data will wait inside SQS until your application comes and fetch for them. Then your application can process them and display them to the end user. But we need to keep in mind something. It's your application's responsibility to tell SQS, hey, I have finished processing this element. You have to remove it from the queue. And then SQS is going to remove it. The biggest advantage of this is that your application can be offline. Your application can come at any time and fetch for the data. This is great. And by the way, when you create an SQS queue, there are some parameters that are needed to be provided. 2 of them are shown in the screen. So the first one is called the message retention period, which is the amount of time a message can stay inside SQS waiting for your application to pull on it. It has a maximum of 14 days. This is plenty of time. What does it look like in practice? Well, you know, AWS makes it super easy by providing multiple SDKs written in different programming languages, including Python, Node.js, PHP. Here is an example in Python. All you need to do is to create your SQS object, get a reference to the queue, and then you send the message. It's only 10 lines of code, and it does the job. Once you execute this, by the way, this is an illustration of this code, the code shown on the screen. It's called the SQS sender. It's the same thing for the reader. You just replace the send message by receive message, and you did the job. It works great. Let's go to the second part, SNS. Well, if you are familiar with MQTT, then SNS is exactly the same. SNS works on the principle of publishers, subscribers. Publishers are the data generators. So they generate data and they send it to something called topics. Topics are channels used to group similar data. Once a message has been published to a particular topic, it will be relayed instantaneously to all the subscribers that are listening for that topic. It's instantaneous, yes, it's really fast. And of course, subscribers can choose to relay the information to the system administrators. And by the way, something good for us is that SQS can be one of the subscribers. Here is a complete list of all allowed subscribers that can be used using SNS. We're going to see later why we use SQS. What about in practice? What about SNS in practice? Yeah, it's exactly the same thing like SQS. You start by creating your SNS object, you call the publish method, and you did it. In this example, I have registered my email as a subscriber to SNS, and I have received the message. We will see in the demo later that actually the publishing and the receiving is really fast. We're going to demonstrate this. Here we come to the most important part of the presentation, the loosely coupled configuration. Basically, loosely coupled applications mean that the components have little knowledge about others, that your system is able to scale, that a component's failure will not affect the system adversely. So can we apply those three principles to our system? Let's see that. Our publishers have no idea about our user's application. Your user application doesn't have any idea about SNS. Your email doesn't know anything about your publishers. Yes, our components have little knowledge about others. We can validate the first point. Does it scale? Well, you can have as many publishers as you want. And you can create as many topics as you want, but you're limited to 100,000 topics. And for every topic, you can have up to 10 million subscribers. That's huge. It's going to take you a lifetime to use all those resources. And by the way, this ability to dispatch messages to multiple subscribers at the same time is called the Fanout. This is coming from electronics. Some of you are going to say, hey, why not connecting SQS to my application directly? So in this case, we're going to come back to the first problem that I have introduced. Your application needs to be online all the time. But by introducing SQS, we are decoupling this. Your application can come at any time, even if it fails. It will come again to SQS and fetch for the messages. And this makes our system fails independently. So let's carry on. There is more with this configuration. Actually, we have something called the policy filters. You can apply a policy filter to SNS. You can tell SNS, for example, to accept only messages that are compliant to some format. If a message is not compliant to this format, then it will be dropped. In this case, we're not relaying invalid messages. We're saving bandwidth and we're saving costs. There is even more than this. If you have some Lambda expressions, it will never get triggered for an invalid message. So we're saving also processing power. And this will lead to saving costs as well. Well, let's carry on. Let's see a quick example. Imagine, for instance, that we have a person, kind of Mr. Robot, for example, who had a physical access to your computer. He tried to authenticate. The authentication failed. So the authentication is going to generate an error, which will be published to a topic in SNS. And then SNS is going to relay this into your subscribers. And the subscribers are going to alert the system's administrator. Hey, it's the demo time. Do you see my desktop, by the way? Do you see my desktop? Okay, that's great. Okay. So imagine now that Mr. Robot has gained access to your computer, and then he's going to try to authenticate. He's going to write some password, for example, admin. And of course, this is not the password. So he's going to try to log in. As you can see, an alert email has been sent to me. Let's try this again. Let's try another password, for example. Let's say system hacked. Of course, this is a wrong password, so it's going to generate an alert. And again, I have received an email. And then my application is going to come and read on the SQS key, on the SQS queue. As you can see, I have read the messages correctly. That's perfect. This is a good example of loosely coupled applications. So let's come back to our presentation. Okay. So let's talk about some of the limitations that you may encounter. In SQS, the maximum message size is 256 kilobytes. If you want more than that, then you have to send your objects into S3 and make a pointer reference in SQS. The second limitation in SNS is that you are limited to 100,000 topics per account. Well, I think this is pretty huge, but you should know about it. If you want more, you have to contact the AWS contact service. But there is something I have noticed in SNS. Actually, when you remove a topic, we don't know if it removes the subscribers as well. So I tried to do the test. It told me that topic was removed. Then I tried to remove the subscribers manually, and it was prompting me with this error. And all the documentation is saying that you need to remove the subscribers first before removing the topic. I actually wrote them a message telling them if they can add something when we want to remove a topic. It will ask us to remove the subscribers as well, because it's very easy to forget removing subscribers. So this is something you need to know. So you have to remember before removing the topics, unsubscribe the subscribers, and it's going to be okay. Okay, so let's conclude this talk. So using loosely coupled applications will prevent your application from losing data, as we have seen in the introduction. Your application can come at any time and fetch for the data and process them, display them to the user. And by the way, SQS is PCI compliant. It is secure enough to hold payment card information. Yes, it is secure. So don't be afraid of security. Amazon is quite secure. There are some people who are telling me, hey, with AWS, it's really difficult to debug. Absolutely not. AWS has excellent debugging tools, and one of them is called the CloudWatch. And on SNS, for example, you can enable something called the status delivery for debugging. And using CloudWatch, you can see exactly what's happening inside your SNS configuration. Okay, so AWS is really reliable, but don't forget you have to use it wisely. It can get expensive quickly, but there are some limits. If you stay on them, it's gonna be free. And there is something good, is that the Architect Associate Certificate is going into this direction. They have increased the number of questions related to cost optimized from 10% to 18%. And this is good. So here are some references. The first two articles are mine. The first one is step-by-step introduction to loosely coupled applications, which is showing how to configure SNS, how to configure SQS. The second one is building a complete IoT system from zero and embedding all the required certificates and exchanging information with Amazon. The third one is the Amazon's blog, which is great. You have always new articles, great articles, by the way. And the two last ones, you can use them if you want to get your certificates. They're going to help you. Well, I guess this is the end of this presentation.